Alright, so today I'm going to go over the graphs of secant and cosecant. Uh-oh, wrong one. Oops, where'd it go? Okay, so let's say, for example, you wanted to do a quick sketch of y equals sine of x plus pi over 4 and y equals cosecant. Uh-oh. Actually multiply both of those by 2. And y equals 2 times cosecant. Of x plus pi over 4. Okay, so first we're going to do the y equals 2 times sine of x plus pi over 4. Okay, so we know our formula is y equals a sine of k times x minus b. That's our formula we're looking for because we have to get the phase shift, we have to get the vertical stretch and shrink, we have to get all of that. Okay, so that means our formula will now become y equals 2 times sine of, there's nothing in front of the, well, after the sine, so that's just 1 times x instead of plus pi over 4 minus negative pi over 4. Okay, so we know our a is equal to 2, our k is equal to 1, and our b is equal to negative pi over 4. Okay, so putting all of that into perspective, we know our interval, which is from b to b plus 2 pi over k, that's going to equal, once you figure all of that out, negative pi over 4. Oh, actually, we got to figure out our 2 pi over k first. Let me do that first. I'll do that down here. Okay, so we know our period is 2 pi over k, which is just 2 pi over 1, which is 2 pi. Okay, so that actually should have been done first. So this is negative pi over 4 plus 2 pi. Okay, so that gives us an interval of negative pi over 4 to 7 pi over 4. Uh-oh, clean all that up. There we go. Okay, so we know our interval. Okay, so that means we know where our graph will stop and where it'll start. Okay, the period just tells you just how wide one cycle is. Okay, so we know one cycle of the sine graph will be 2 pi. Okay, we also know our amplitude, which is the absolute value of a, where in this case is just the absolute value of 2, which is 2. And that just tells you either how high or basically how high your graph goes. And our phase shift, which is b, is equal to negative pi over 4. And that lets you know it's going to shift left pi over 4 spaces. So we're going to put all that into perspective when we kind of graph it against regular sine. Okay. So if we have our, I'll go down, should be enough. Okay, so let's say if we just graph our regular sine. That a little bit more. Yeah, it's not really even. See if I can even it up a little bit more. Alright, that's good enough. Okay, so that's from 1 to -1. We bring that down a little more since we know our amplitude's going to increase. Bring this up a little more. Okay, so this is just our regular sine. Nothing special about it. This is just our regular sine of x. Okay, we know it goes from -1 to 1. We go from pi over 2 pi, 3 pi over 2 to 2 pi. So we know sine equals 0 at pi and 2 pi. We know sine of pi over 2 is equal to 1, and sine of 3 pi over 2 is equal to -1. So we have our sine graph. Okay. So now we know this is going to shift to the left pi over 4 units. So let's say this is our negative pi over 4. That means this point is going to shift here. This point is going to shift here pi over 4 units. So we know that pi minus pi over 4 is equal to 3 pi over 4. So this is actually going to shift here to 3 pi over 4. And this is going to shift here because 2 pi minus pi over 4 is 7 pi over 4. Okay, so normally you want to get all the points that intersect your x-axis. Those are the ones you want to make sure you know where they're shifting to. So all of those points are going to shift left pi over 4. Okay. So we also know our amplitude is equal to 2. Now our amplitude is just the height of our graph. That's our amplitude. Okay. So in this case, our amplitude is 1. But we know that by our amplitude being 2, this graph, not only is it going to shift, but it's going to stretch from 2 to -2. Okay, so that means this graph now looks like, let me see if I can do this without completely messing it up, since everything shifted and go from there to there, and -2 is going to go from here to here. Actually, it wasn't bad. Shocked myself. I was expecting to completely ruin it. All right. So that's how your new graph would look. You now have an amplitude of close enough to 2. Let me lower that. I don't want to press my luck by trying to redraw it. Okay. So here your amplitude is now 2. The graph now shifted to the left pi over 4 places. Okay. So we have everything kind of figured out now. Okay, so this is the graph where we know that this is our sine of x. But this is now our graph of y equals 2 times sine of x. You can say minus negative or plus pi over 4. Okay, so they kind of told us everything we needed to do. Okay, any questions on that so far? All right, so from there, I'll leave that up for a little bit. Make sure everybody got it. All right. Now from there, I'll leave that there and kind of start the next one where that one ends. Okay, so since we know that, what was that, cosecant of x is equal to basically the reciprocal of sine of x. We're going to use the sine of x graph to graph our cosine of x. All we have to do is find the integrals for our cosine of x, cosecant of x. Why did I say cosine? The integrals to where our cosecant can equal a denominator of 0. A lot of cosines and cosecants being thrown around there. Okay, so we know. So to graph y equals 2 times cosecant of x plus pi over 4, actually, if we go ahead, we know that's just going to equal 1 over 2 times sine of x plus pi over 4. So we're just going to get that entire graph and flip it. Okay? But there's one thing we have to do before we do that. First thing we have to do, find out where 2 sine of x plus pi over 4 equals 0. Okay? Because we know it can't equal 0, you have a denominator of 0. So before we can graph anything, we have to find out where our vertical asymptotes are. Okay. Now, let's say if we didn't graph this beforehand. There's actually a way you can do that without graphing it beforehand, but even though you're going to have to graph it. Okay. So we know that sine of x equals 0 when x equals 0, either positive or negative pi, positive or negative 2 pi, positive or negative 3 pi, and it keeps on going. The further you go down, it's still going to equal 0 at those points. So that means if you have 2 sine of x plus pi over 4, that will equal 0 when this equals 0. When x plus pi over 4 equals 0, positive or negative pi, positive or negative 2 pi, etc. Okay. So that means on our x-axis we have to subtract pi over 4 on both of those spots. So if we subtract pi over 4, subtract pi over 4, subtract pi over 4, and we're just going to deal with the positive for now, and subtract pi over 4, that means x would have to equal 0 minus pi over 4 is negative pi over 4. Pi minus pi over 4, if you notice we figured that out already, it's 3 pi over 4. Like I said, we're just worried about the positives for now because we're only doing one cycle. So we'll take out the positive and negative. Okay. And you have 2 pi minus pi over 4. If you notice, we did that already. 2 pi minus pi over 4, 7 pi over 4. And it keeps on going. Uh-oh, sorry about that. Didn't bring, thought that was in screen there. Okay, so those were all the sections. If you remember all the sections that intersected the x-axis, those are all the ones we figured out just how far we had to shift. So if you did this up here, you really wouldn't have to do this part. But this is just, in case you didn't do that and you decided to wait and graph last minute, you could have done it that way also. All right. So these are all the places where your denominator would equal 0. All vertical asymptotes where the denominator equals 0. Okay, so I'm going to go ahead and redraw this one, just so we don't have to worry about. Okay, so let me go ahead and redraw it. Bring that up a little bit. Okay, so remember it did shift. Okay, and it went from -2 to 2 on our x and our y. Okay, and this is our 3 power over 4. This is our negative power over 4. And this is our 7 power over 4. Okay, because remember, this is just our graph of, actually I probably should have, I'll do that later. This is our graph of y equals sine of x plus power over 4. All right, so that's just the graph we already drew. Okay, so we know already these are our vertical asymptotes. Oh, straighten that up a little bit. Okay, so these are all the values we can have equaling 0. Let me straighten that out a little bit more. Okay. Now, what I normally do is just slightly erase this because I don't want this to be the graph that gets the most attention, because we already graphed this. So just lightly erase that when you just kind of want a faded version of it. Because now we're looking for the reciprocal of sine, which is cosecant. So between each value where the denominator is equal to 0, we're going to flip it. So between these two vertical asymptotes, we're going to flip it. And between these two vertical asymptotes, we're going to flip it. Okay. So now where we flip, those are actually representing the graph of cosecant, well, 2 times cosecant of x plus power 4. Okay, so the first thing you want to do is you want to graph sine, and then wherever you graph sine, you flip it. And you do the same thing for secant. First thing you do is you graph cosine, then as soon as you graph cosine, you flip it. All right, so any questions on that one? All right, so we'll do one more. Everyone's still writing. Leave that up for a few seconds. Okay. Okay, so quick note to graph cosecant. Clean that up a little bit. First graph sine and flip between the vertical asymptotes. Okay. Now to graph secant, we do the same thing, but we do it with cosine. To graph secant, first graph cosine. I'll make sure I kind of highlight those. And then flip between the vertical asymptotes. Okay, so to do that, really two things you want to remember. Because before we needed to know everywhere sine was equal to 0. So sine of x equals 0. When x equals 0, you can say positive or negative pi, but you don't need to know the positive and negative. But positive or negative 2 pi, positive or negative 3 pi, pretty much any number times pi, any whole number. Well, we might as well say integer. Any integer times pi will make sine equal 0. 1 pi, 2 pi, 3 pi, 4 pi, etc. and so on. Now with cosine of x will equal 0, here when you have any odd number times pi divided by 2, let's say when x is equal to, let's say, instead of 1 pi over 2, say pi over 2, positive or negative, even though we're mostly only going to use the positives, just to be thorough. Positive or negative 3 pi over 2, positive or negative 5 pi over 2, and it keeps on going to just some 2n plus 1 pi over 2, or 2n minus 1. 2n minus 1 works better. Okay, so any odd number in the numerator times pi, that's where your cosine will equal 0. And those are the ones you don't want when you're graphing, which one is cosine? So that would be secant. So let's say, for example, I'll start on a new page, since I'm pretty sure I won't be able to finish it up on that one. Let's say if we want to do a quick sketch of y equals secant of x minus pi over 4 plus 1. Okay, so the first thing you want to do, you want to find out what all those numbers are telling us. So we use our y equals a times cosine k times x minus b plus c. And we line it up with our y equals, instead of, secant. Actually, your cosine, that's the one we're starting with. 1 times cosine, and we'll say of 1 times x minus pi over 4 plus 1. Because remember, this graph secant, you got to start with cosine. Okay, so we know here our a is equal to 1, our k is equal to 1, our phase shift is power of 4, and our C is equal to 1. That 1 is just where we shift the whole graph up 1 or down 1. Remember, our f of x plus c means we're going to shift it vertically up or down c number of places. This just lets us know we're going to get that entire graph and shift it up 1. Okay, so we know our amplitude, which is absolute value of A. Actually, just to change it up, I'll make that 2. I want to actually get everything to have a value, so we can see how everything goes. So we'll change that to 2. Okay, so absolute value of 2 is 2. Okay, so we know our phase shift is equal to B, which is equal to power of 4. Okay, so if your phase shift is positive, you know you're going to shift right. Only because you know when it's x minus b, you're going to shift right. When it's x plus b, you're going to shift left. This is just another way to say pretty much the same thing. Okay. We also know our interval, which is b, and b plus 2 pi over k. Nope, did it again. You have to know our 2 pi over k. Our 2 pi over k is our period. I don't know why I'm always jumping to the interval first, but our period, which is 2 pi over k, ends up being 2 pi over 1, which is 2 pi. Okay. Now our interval, now that we know our 2 pi over k, is power over 4, which is our b, and power over 4 plus 2 pi. And should have moved that over some. So it's power over 4 to 9 power over 4. And I think I will move that over a little bit, instead of trying to squeeze everything in that little bit of space. Okay, so our interval, we know that's b, and b plus 2 pi over k, which is power over 4, power over 4 plus 2 pi. Still ran out of room. Power over 4, 9 pi over 4. And not too bad. It's readable. There we go. Okay, so we have our period, our phase shift, our interval, and our amplitude, which is everything we need to make a graph. Okay, and we even have one more, our vertical shift. Which is C. Which just means you're going to move everything up 1. Okay, so we're going to go ahead and graph our cosine using everything we have here. All right, and we're going to line that up against just regular cosine. Okay, so we have our x and we have our y. We're going to do a quick graph of just regular cosine. Okay, so that's just one cycle of cosine. Okay, so remember, it becomes 0 at